The TRS Prosthetic Simulator is the first standardized simulator technology ever made commercially available. It features a low-temperature, thermo-formable body and frame, BOA cable closure technology, and TRS Sherlock cable locking technology. Additionally, it includes a Hosmer 5XA voluntary opening split hook and a TRS voluntary closing Grip 3 prehensor. We also supply it with a fully adjustable Northwestern Figure 9 harness and cable system. The TRS Simulator will immediately fit a wide variety of arm sizes because of its flexible material and BOA closure system, but is designed to be able to be custom molded to the evaluator's arm for a precise fit if that is desired. Place the simulator body without the terminal devices or harness attached and with the BOA system loosened in an oven set at 130 to 150 degrees Fahrenheit for approximately 10 minutes until the material is soft and flexible. Please never expose the simulator to temperatures that exceed 150 degrees Fahrenheit. Loosen the BOA cable closure by pulling up on the knob, then grasp the small handle yoke on the cable, allowing the simulator closure to loosen up along its entire length. Push in the knob and turn the knob clockwise to tighten the cable system back up when fitting on a user. The Velcro closure tab can also be opened to release the cable system enclosure. The warm, soft simulator body, once taken out of the oven, can be slipped over and molded to form around the user's arm. Tighten the BOA closure to a firm fit and let the system cool until the body is formed more rigidly. The terminal devices screw into the wrist on the end of the simulator. A small Allen-style fitting screw in the wrist allows the terminal device to be friction locked in place. This screw is adjusted using a small removable Allen wrench magnetically attached to the simulator's medial side for your convenience. Position of the terminal devices is variable and they can be canted to suit the particular activity that is being attempted. The Figure 9 harness is fully adjustable. First, adjust the axilla loop around the user's contralateral shoulder so that it completely and comfortably encompasses the shoulder and the harness ring sits on or slightly off the vertebra towards the contralateral side. Attach the cable fitting into the terminal device. Now tighten, shorten the control strap attached to the hanger fitting and cable so that when the prosthesis is relaxed, hanging along the side, there is slight tension in the system. The cable is not slack and any shoulder or arm movement will begin to operate the terminal device. When the forearm and the prosthesis are flexed to 90 degrees, the VC prehensor should be pulled closed, specifically adjusting voluntary opening. Tension the strap so that the hook remains closed while alongside the body, but begins to open with any shoulder or arm movement. Flexing the forearm and prosthesis to 90 degrees should pull the hook open. The split hook TD may need to be held fully open to more easily hook up the cable. The 5XA hook is supplied with 2 or 3 elastic bands installed. Decreasing or increasing the number of bands will alter the amount of energy that is required to operate the hook and impact its maximum prehension. Prehension is inversely proportional to the force created by the user, but directly proportional to the magnitude of closing force created by the elastic bands. If more direct control over the terminal device is required, then shorten or tighten the control strap. Also note that the harness may need to be removed off the shoulder to slacken the cable tension to more easily facilitate changing of terminal devices and/or the attachment of the cable fitting to the terminal device. These are the basic motions used to control a terminal device with a body-powered prosthesis. Glenohumeral flexion. Reaching forward with your arm fully extended creates excursion and increases cable tension. Unilateral or bilateral scapular abduction, shoulder rounding, creates excursion and increases cable tension. Elbow flexion, flexion of the forearm, creates excursion and increases cable tension. Humeral abduction, raising arms laterally with the elbows flexed, creates excursion and increases cable tension. Bilateral shoulder elevation, shoulder shrugging, reverses excursion and decreases cable tension. And scapular retraction, squaring shoulders, reverses excursion and decreases cable tension. First, it's useful to just grasp a finger or fingers of your hand to experience the pressure that can be created by the terminal device. Sherlock technology is installed on the simulator to increase the versatility and function of both the voluntary opening and voluntary closing terminal device. The Sherlock mechanism engages the bare cable inside the mechanism, preventing it from moving distally. The cable can still be pulled in proximally when the mechanism is engaged. Engage the Sherlock mechanism by pushing the actuation yoke forward, distally, while the thumb of the prehensor is completely open. Reach forward and grasp an object. You can size down on and grasp the object and then relax cable tension. The object will remain in the terminal device. Or grasp the object first, then engage the Sherlock by pushing the yoke distally forward. To release the mechanism, apply slight tension to the cable as you pull the yoke back proximally to release the mechanism. Voluntary opening system operation. To grasp, open the hook terminal device and allow it to size down on the object to be grasped. Actuate the Sherlock mechanism by pushing the yoke forward distally to lock the fingers in place. To release, apply slight tension to the cable as you pull the yoke back proximally to release the mechanism.